Welcome, Alex.
Thank you. So, I'm Alexandre Mattioli, cloud architect at ShapeBlue, been some 30 plus years in technology, working all kinds of fields of IT, and been involved with CloudStack for about 10 years, built a quite large global cloud. I'll be talking about this new integration, Tungsten Fabric with CloudStack that came out in 4.18. For core and edge zones, but in this case, edge zones are not the new construct, are just the idea of remote zones, really small hardware. But soon we should be able to use Tungsten Fabric with CloudStack edge zones as well. So with this integration, I've been involved after the integration was done, been testing, documenting, and trying to see what I can build with that. So for this presentation, I have a small POC that I did part of my own home lab and ShapeBlue lab using Tungsten Fabric with 4.18 and a little bit of 4.18.1. So I have 4 zones, just standard CloudStack zones. One's core, the other 3 edge zones. Those were originally located actually in these places, but I rebuilt all in lab because of some bandwidth issues. And I want to get to this solution where I can route any traffic from networks from the edge to the core and just HTTP and ICMP between edge nodes. This is nothing new. Everyone builds solutions like that. But the problem is you couldn't do that with isolated networks. With VPCs, IPsec, that doesn't scale that well. Is a quadratic problem to do a full mesh. I highlight there 450 nodes because I worked on a project that needed a full mesh of 450 nodes, and that's 100,000 tunnels. You can do that to some commercial SD-WAN solutions, but very, very expensive. So what's the solution now? Open source cloud orchestration with open source software-defined networking, Tungsten Fabric and CloudStack. So we'll talk a bit about this integration. First, thanks to Samuela, who is here, working together with Sven Vogel, got some developers together, and us at ShapeBlue got involved later on. Many of my colleagues helped quite a bit with this, and we'll all continue working on this integration. What's Tungsten Fabric? Tungsten Fabric started as Contrail at Juniper, became Open Contrail, then Tungsten Fabric, which now is managed by the Linux Foundation, same history as CloudStack, became fully open source. It has a very large community, is used in production in many places. It's very tried and tested technology. It historically integrations with Kubernetes, OpenStack, VMware, and now finally CloudStack. How does it work? The orchestrator, in our case CloudStack, pushes to the Tungsten Fabric controller policy definitions, how I want traffic from network A to go to network B. And that's enforced in the hardware level directly in the kernel. So you don't have a virtual router VM that works directly in the kernel. And the logical view there, you have blue and red networks. Those are actual independent VRFs. For those who don't really know what VRFs are, puts very simply, those are layer 3 analog of VLANs. And everything is VRF based on Tungsten Fabric and most SDN solutions. Another view of that, you have there your virtual networks, connectivity between them, certain ports here and there, and physically that's all controlled. That goes through your underlay. It's all programmed in the kernel module. Typically, is a kernel vrouter in your KVM host. It has other options, but vast majority of cases is just a kernel module. and that's how I actually built this environment. Tungsten Fabric itself is all microservices, runs in containers. It's very, very scalable. You can choose where you want to run your UI, database, everything. Now let's see how to deploy a Tungsten zone in CloudStack. I could have done this as a live demo, but as Giles has proven earlier, live demos don't always work, and it would be just too much clicking around. But I have this environment ready. Anyone who wants to see it later, just let me know, can show over a beer. In CloudStack, we have that global setting to enable Tungsten. If you don't enable it, most things still work. At the very end, it fails. So remember to enable it, and just gotta say, it's a few hours of my life I'll never get back. There's new network services, Tungsten, just like all the other network providers, and the full offering. We create a zone, advanced zone, as we want layer 2 segregation. In this case, it's actually layer 3 segregation, but it's the advanced zone. We have a new isolation method. Tungsten Fabric is at the very bottom of the list. And for your traffic types, they work the same. You just select which interface. The way Tungsten Fabric works, you present to it ETH0 or bond 0. In this case, I use just one single interface in my hypervisor, no bridges, nothing. And Tungsten itself creates this VHO0 interface that's bound to your physical interface. So all my traffic labels are VHO0. So very, very easy to set up. When you have a Tungsten enabled zone, you have this new page that Giles showed before. The provider name, you can enter whatever you want. The host name, that's your actual provider. And you can have one for all your zones or one per zone, depends on your network topology. But in this case, it's just one fabric for all my zones, and that's how most service providers would run that. That gateway, that's mandatory in the UI, but not in reality. That's just how the integration was created. That's for a virtual gateway to go between the fabric and your external networks. In this case, I'm using BGP, so that gateway, I can just place an IP that will not get used. I create my public range with no VLANs. The isolation will be in VRFs. Same for the pod management. The rest of the wizard is just the same, primary, secondary storage, etc. At the very end, you can see that is creating Tungsten Fabric public network and also the management network, which are created in the fabric. That's in the Tungsten UI, my management public, so you don't need to create upstream gateways for those networks. Tungsten will take care of that. One caveat, if using BGP or what Tungsten calls gateway-less setup, in your public network, you need to enable IP fabric forwarding. So your traffic goes from your overlays and out through your underlays and any external networks. So back to my 4 zones, I want to create my networks now. I just create them as isolated networks using the Tungsten offering. It's important now that these seeders are different. These isolated networks won't be that isolated anymore. That name is getting a bit old. Create a network in each of my zones with a different gateway, different seeder. Have all my networks there in place with isolation method Tungsten Fabric, and on the Tungsten UI I can see my networks there, and the integration applies certain network policies already to those networks. So far I have this. I have one network per zone, and the routing out to the internet still goes through SourceNet. Tungsten Fabric also implements that. Deploy my VMs, that's nothing new there, so nothing to show. Those VMs just to see how the traffic can be steered between those networks. And then I need to create network policies. In Tungsten Fabric, as I mentioned, each network is its own VRF. There you have red and green VRF. Traffic's tunneled through hypervisors using MPLS over GRE or UDP, VXLAN. Tungsten chooses whatever works better at a certain moment. In CloudStack, in networks, we have that new tab, Tungsten Fabric, with list of providers. In this case, all my providers are the same, so if you click in any of them, you'll just get to the same provider, but it could be different ones as well. There just shows the details of my provider, but this is where it gets interesting. There's lots of functionality there, and to talk about all of this, I will need at least 10 hours. So I'll focus just on network policies right now. I create a new policy, just called routing policy. Not more than that. And on the network itself, there's a new tab, network policy, that you attach your network to a policy. So you're basically turning that quadratic problem into a linear one, way less overhead. Same for all my other networks. They are all now in the same policy. In the Tungsten UI, I can see that all my guest networks connected to that policy. So far, the policy doesn't do anything. The policy needs rules to know how to steer the traffic. So next, I will create the rules. I can create rules between source and destination CIDRs or networks. There's a very peculiar naming format there, not very user-friendly, something I expect to change in the future. But there I'm basically creating a policy to allow all traffic between my Prague network and my Sofia network, that just any bidirectional. But it can be any port of any protocol, can be between network ranges or anything. I create then the same policy for my other edge zones back to the core, and they are there created in Tungsten Fabric. And I get to this. I can pass any traffic between my edge sites and my core sites. So any sensor data or the control plane back, camera, any IoT services going back to the core. And now I want to allow the traffic between my edge sites. So I created the same rules, allowing ICMP, HTTP, allowing ICMP just for monitoring, HTTP maybe for object storage, replication, something like that. I have all my rules there in Tungsten Fabric, and I can have way more rules, and I can simplify this. This scales from 3, 4 zones to hundreds, thousands, tens of thousands. Depends on how you create these rules, and it's much simpler to create this than any kind of VPN. Before the policy, my VM in Prague could not reach my VM in here, and after the policy, it pings, just as if it were connected to the same router, because it is actually connected to the same logical router going through the kernel directly. There's no CloudStack virtual router anywhere, which also means that it scales as your hypervisor infrastructure scale. The more hypervisor you have, the more routing capacity you have. And the traffic between my zones, my networks in the zones go through this overlay, but out to the internet still goes locally. So there's no need to backhaul traffic to a central site. And that's how I get to this solution. So have my source NAT in each zone, HTTP, ICMP between my edge zones, and any traffic between edge and core. So the steps for that were just deploy the zones with Tungsten Fabric, isolation, create my networks, deploy my VMs, create my rules from edge to core, and create my rules between the edge sites. Now let's see how this looks in Tungsten Fabric, a little under the hood of Tungsten. Tungsten makes this nice diagram, which looks pretty much like mine. You can click there and see the bandwidth and everything. List of network instances, interfaces. You can get a lot of metrics there. You can see exactly the flow from point A to point B, which is very important for monitoring, compliance, all kinds of things. You can enable QoS, logging, mirroring in any network. Those are things which are not integrated in CloudStack yet, but you can go and enable directly in Tungsten Fabric. How does it do this connectivity? Overlays. So it does layer 2 and layer 3. For layer 2, it uses VXLAN. For layer 3, MPLS over UDP or GRE. It just places a priority order, and Tungsten will choose what works better. You can set up BGP peering directly from the Tungsten controller. And before anyone asks, you can also use that for your management plane, especially useful for edge sites. You can deploy your Fabric, your KVM hypervisor, then deploy your CloudStack management server, database, etc. in that Fabric. And then use the same Fabric for your zones. That just makes it much easier to connect all your hypervisors to your management server. That's how I built this solution, just over the internet, using the internet itself as the underlay. Had to go pretty low MTU though. So the integration itself, what has been integrated and what hasn't. In the classic UI for isolated networks, nothing changes. Same user experience, great networks, port forwarding, load balancing, with the caveat that you need a public IP for each service just because of how Tungsten Fabric works. But also because of how it works, that's less of a problem. And on the Tungsten tab, you have lots that you can do from there. You can create all kinds of steering policies with service chaining, all kinds of stuff. And there's lots of interesting features in Tungsten Fabric that haven't been integrated yet. I highlight a few that I find personally very interesting. You can do EVPNs, QoS, service chaining. You can just tell Tungsten Fabric that to go from VM A to VM B, or the set of VMs to the set of VMs, you have to pass through the set of firewalls. And if the traffic's a different port passes through this IP SIDS, you can just steer traffic in any way you want. You can have BGP as a service for each isolated network running their own BGP session, which is quite interesting as well. And I'm sure there are lots more features that I just haven't found yet. These are some enhancements that come to mind in the integration. So far, the isolated network, it is created for your domain. The other features are only on the root domain, so that's something that needs to work on at some point. IPv6 support. Tungsten supports VMware. I'm still not sure if that makes perfect sense, but there's lots that we can add to this integration. So how is that set up in CloudStack? Requirements, not much on the hardware side, nothing new there, any old hypervisor will do. Connectivity, you just need IP, IP. You need one network interface with one IP address, and that's all. All the traffic is gonna go on top of layer 3 anyway. We have tested with CentOS 7.6, Ubuntu 20, and Rocky. Did not manage to get to work with Ubuntu 22 yet. With 4.18, you can have one zone per fabric. There is a patch already to have multiple zones in the same fabric, which is what I use here. And that should be available on 4.18.1. The KVM setup, very simple, no bridges, one interface. And this works fine in nested environments. It's very easy to run a proof of concept. So some of my zones were nested, some were not, and it works just fine. The deployment of Tungsten Fabric is all container-based as well. We have there, we just download the image. We have a public one. A colleague of mine, Wei, created a script to deploy everything in CentOS to take care of all the dependencies, and that took us a few weeks of brainstorming to get exactly each version of everything, but now we have this nice script. Then to deploy your fabric, you have these two Ansible playbooks, configure instances and install Contrail. And the key thing there is this instances YAML file that has the definition of your entire infrastructure. And we added there a ACS example file. There were example files for everything else, so we created one for CloudStack. There in the left, that's the sample file for CloudStack. On the right is the sample file. This is the actual file that I used for this environment. And after running that Ansible playbook, the controller node has all these containers, which here you see all those roles. You can also distribute them in many servers. You can scale that horizontally. You can deploy new ones later on as well. And on your KVM host, you have this vrouter agent that actually programs the flows in the kernel module. And I also have an environment ready to go to deploy all of this. So if anyone is interested checking that out later, just let me know. And that's it.
Live demo, eh?
Huh?
You can live demo, eh? Prepare in the pub.
In the pub, where we can deny.
Playing Wi-Fi. Any questions? Any questions for Alex?
I got two questions.
Yes.
So IPv6 is on the roadmap. You kind of guessed this question for me, but do you know how far the code has been prepared for it? So when with development, did people think about it already, or is this going to be a major overhaul of the code?
I actually don't know then, so I just haven't tried IPv6 because now isolated networks support IPv6, so it might be just a matter of creating an offering.
Yeah, because Tungsten Fabric supports it. I know
It does, absolutely does.
For years.
It shouldn't be much work. Simon can answer that better, probably.
We didn't test the use case, but it should work.
Yeah. Okay.
It should be very minor if something needs to be fixed. But as you said,
Yep.
you know, Tungsten supports it. So
Yeah. And then my second question was regarding MTUs. This is always a problem, of course, when going over IPsec tunnels and going over public internet, and you get MTU like 1480 within your tunnel. The same applies if you're using VXLAN. So you did your testing, I guess using the public internet as connections between those edge locations.
Yeah.
But does it do anything with setting the MTU with the VR to something lower nowadays? Because that's a functionality in 4.18. Does it do it automatically yet?
That's a separate functionality. So here DVR is on the kernel module.
Oh yeah, true. Yeah.
So it just goes through the kernel.
Yeah.
I went down to 1420 just because I was going through firewalls back at home in Brazil.
It probably uses the MTU path discovery, right? That would be my guess.
I hope it does.
Yeah.
No, it actually does, yes.
So,
between two VRFs in the lab, it was going close to 9,000.
yeah.
Okay.
Yep. And the encapsulation method as well. It decides what's better at the moment, UDP or GRE, which is quite interesting. And so far has been integrated for layer 3, but shouldn't be that much work to be able to create VPNs.
About software, will it run on Arma Linux?
Sorry?
On Arma Linux.
We haven't tested that, but I don't see why not. It's just a matter of trying to run the playbooks.
It works on Rocky 8, so it
Yeah,
should,
yeah.
it should work on Alma 8 without a problem.
Okay.
Yep.
They're binary compatible, so.
Any more before the live demo? No? Thanks, Alex.
Thank you.